Welcome to this explainer on the architecture of Codatta DID. Okay, let's dive into this. We're looking at one of the most high-stakes, fundamental problems in all of Web3 right now, digital identity. For years, we've been building all these incredible decentralized systems, but the way we actually identify ourselves within them, well, it's remained incredibly fragile. Today, we're going to break down how Codatta is completely rethinking this from the ground up. They're engineering an identity layer that actually belongs to you, not to a blockchain.
Just think about how crazy our current reality is for a second. In the physical world, if you lose your leather wallet, it's a massive headache, right? You gotta cancel your credit cards, order a new driver's license, more than the loss of that $20 bill, but you don't cease to exist. Your identity remains perfectly intact. In Web3, however, we've accepted a very different, very dangerous premise. Your identity is chained directly to your wallet. If you change your wallet, you effectively become someone entirely new. And if you lose your private keys, you permanently lose you. Imagine spending years building a reputation in a DAO, earning airdrops, establishing trust across communities, only to have your entire history, your reputation, and your access wiped out in an instant just because a key was compromised. No way.
So here's our map for today to understand how we actually fix this. First, we'll examine that flawed identity assumption. Next, we'll unpack the Codatta DID solution itself. Then, we'll look under the hood at its high-speed architecture, explore how it guarantees true ownership and privacy, and finally, we'll see how this infrastructure fuels the upcoming agent economy.
Section 1, the flawed identity assumption, or what we can call the wallet trap.
It's honestly a bit frustrating how accustomed we become to this limitation. We've treated this wallet trap like a feature, just because it's all we know in the decentralized space. Traditional decentralized identifier schemes, like the Ethereum-based DID.ETH, tightly couple your identity to a specific account. The identifier essentially is the wallet address. Now, what's really interesting about this slide is how Codatta breaks this assumption entirely. Their premise is that identity equals you. It is fully decoupled from any single chain or any single private key, illustrating a massive, game-changing paradigm shift for how we handle our digital selves.
Moving on to Section 2, the Codatta DID solution, decoupling identity.
So if we aren't using a wallet address, what exactly do we use to build this globally portable, self-sovereign layer? The answer lies in something called a UUIDv4. Basically, this is an on-chain, randomly generated identifier formatted as DID Codatta. Because it contains absolutely zero chain-specific information, it acts almost like a digital birth certificate. You can think of a Codatta DID as the permanent ID card you keep in your pocket. If your Ethereum wallet gets compromised, or you just decide you want to move to a new address for better security hygiene, you simply transfer the ownership of your DID to the new address. You don't disappear. You don't start from scratch. The identifier remains exactly the same, preserving your entire digital history seamlessly. And because it isn't locked to one specific chain's cryptography, a single Codatta DID can actually aggregate all of your verification methods into one unified profile. You can bind your traditional Web2 credentials, like an email challenge or a Google Auth login, right alongside your Web3 credentials, whether that's an Ethereum address or an address on a completely different network like TON. It creates one seamless identity spanning multiple ecosystems. This is an incredible blend of Web 2 and Web 3, totally eliminating those single points of failure while maximizing flexibility for us, the users. Section 3, architecture built for speed. Let's talk about the 4-layer engine. Building an identity system that spans across multiple chains and handles this much data, that requires some serious engineering. I mean, if you put every single query on-chain, the latency would bring the whole user experience to a grinding halt. Let's move to Coda and see how this builds to solve the blockchain bottleneck. Coda adopts an incredibly smart 4-layer architecture. At the foundation, you have the contract layer handling on-chain storage and access control. Next up is the indexer, which is constantly monitoring on-chain events and syncing them to a high-performance off-chain database. Above that sits the resolver, providing a standardized interface for reading that data. And finally, the application layer, which is where things like your login and authorization calls actually happen. This separation is honestly genius. Write operations, the actions that actually change or update your data, those go directly on-chain to ensure absolute security, transparency, and immutability. But the read operations, those go off-chain through that indexer for high performance and extremely low latency. And here's why this is absolutely crucial. The off-chain index is purely an accelerator. If the off-chain indexing service completely drops offline tomorrow, you can still retrieve your full DID directly from the blockchain. There is a built-in fail-safe mechanism. Sovereignty permanently remains with you, and your data is literally never lost.
That brings us to Section 4, True Ownership and Privacy. Let's look at controlling your data.
When you start attaching custom attributes, personal emails, and multi-chain addresses to a single identity, data management and privacy become the absolute most critical pieces of the puzzle. I really want you to let this quote sink in for a second. A Codatta DID belongs to its holder, not to Codatta. This isn't some platform-specific credential. It avoids platform lock-in entirely. To ensure you actually own it, Codatta introduces a brilliant controller mechanism. The owner of the DID holds the ultimate authority, but they can actually add other DIDs as controllers to manage the document on their behalf. Imagine a massive enterprise DID that needs to authorize dozens of employee DIDs to manage data. They can now delegate that authority smoothly, transparently, and without ever sharing a single vulnerable private key. So the crucial point is how this system handles the privacy of all that rich data. Traditional schemes only really deal with public wallet addresses, so on-chain exposure isn't a massive privacy risk. But Codatta handles highly sensitive personal data, stuff like emails and Google accounts. To protect you, Codatta uses a hash plus salt approach. This means the actual plaintext of your email is never, ever exposed on the public blockchain. Only a cryptographic hashed value is stored on-chain, and the verifying party supplies the original value and a unique salt for a match. This guarantees perfect verifiability while completely preventing malicious actors from reverse engineering your info or tracking you across different platforms. And this true ownership extends to the developers building on this infrastructure too. Traditional identity schemes usually mash registration and data management together into one highly coupled smart contract, while Codatta separates them. Think of the DID registrar as the front door and the DID registry as the secure vault inside. The registrar is an independent entry point, while the registry handles all the core data. Why should you care about this? Because it means developers can plug in multiple registrars at the exact same time. You could have one registrar for free users, one for paid premium users, and one for batch enterprise onboarding, all interacting with the exact same core registry. Developers can iterate and change their entire business model without ever risking the core data layer. Section 5. Fueling the agent economy beyond human identity. Up until now, everything we've talked about has centered around human users. But we're looking at an infrastructure that extends way, way beyond that. Enter the agent economy. With upcoming compatibility for ERC 8004, which is an Ethereum standard designed specifically to allow smart contracts to own and manage their own assets, Codatta is allowing AI agents to hold their own distinct identities. An AI agent can hold a Codatta DID and participate in the network completely autonomously. They can act as data labelers, validators, or even downstream data buyers, closing complex economic loops entirely on their own, without a single human intervention. How wild is that? And this brilliantly illustrates the real endgame here. When you pair an agent's Codatta DID with the ERC 8183 standard, which is designed for autonomous task distribution, you get this seamless, fully automated pipeline. Agents are discovered on the network, tasks are efficiently executed, the work is cryptographically verified, and the payout is settled, all running end-to-end on-chain. Codatta isn't just an identity layer for people. It's actively positioning itself as the foundational identity and settlement infrastructure for the entire automated EVM economy. That's the sprawling network of decentralized applications built on Ethereum and its compatible chains.
We've covered a massive paradigm shift today, from escaping the wallet trap to building a high-speed, cross-chain, privacy-first identity standard, all the way down to laying the tracks for an autonomous AI economy. It leaves us with one incredibly exciting thought to walk away with. When human identities finally outlast the chains they're built on, and AI agents are out there managing their own verifiable wallets and workloads, what will you build next? Thanks for joining me for this explainer, and I'll catch you next time.